Hello everyone. So my name is Khemon Beh. I'm a managing data scientist at Capgemini Invents, working with my teams on putting AI solution to production. Actually, working with the different phases of the AI product, from the ideation phase of defining the relevant use cases to building the solution and ensuring the adoption when it's deployed in production. So I'm really pleased and enthusiastic to share with you maybe some of the lessons learned over the years with the different projects we had with our client across different sectors and industries, and why we think human in the loop is at the core of the success of a given AI project. And the the main focus of this presentation will be to give a little bit of an idea of what the human in the loop landscape is about. It's actually a broad field that goes beyond just labeling, and it's getting a lot of traction these days because of again a lot of different enterprise facing the challenge of putting the solution to production. And human in the loop is really how to interact and in an efficient manner between the human and the machine to make it accurate and trustworthy. So my presentation will be twofold. I'm gonna define a little bit what human in the loop is, what are the concepts behind it, why is it important in AI projects, and we're gonna have a second part where we're gonna deep dive into concrete examples of projects where we learn some what is now principles for us when we start new project. What are the lessons learned, that what's can be the takeaway for you if you're starting a new project with a human in the loop based solution. So without further ado, human in the loop, like I just mentioned, is far beyond just labeling. I tried to come up with a definition. It's basically a set of methods where you want methods and concepts for making humans and machine work effectively, and aims at training, evaluating, interpreting machine learning models with minimum costs by integrating human knowledge and experience. So in a traditional, let's say traditional machine learning setup, when you want to build your system, if you are working in a supervised learning setting, you're going to collect some data, you're going to annotate and label those data, and these will require human expertise. And what is truly, I would say, different from, I would say, academic experiments is that in the enterprise, most of the problem, the real world problem we have in the enterprise, is that data collection and data labeling requires really, really scarce domain expertise. And this is why human in the loop methods are really helpful, because it helps with the burden of soliciting those expertise that is those resources that are quite scarce and valuable in the company. And but we'll dive in one moment. So it's really a key lever to secure the success of the AI project, and we'll talk about examples in different sectors, where if you think about human in the loop by design in your solution from the beginning, and you incorporate those, some of the key principles we're going to talk about, uh, you can't go wrong, basically. So the human in the loop landscape that I try to put here, it's by no means exhaustive, but it gives you some of the main areas where the community is focusing on. And it starts off with machine teaching. And machine teaching is what everybody that, when we talk about human in the loop, thinks of at first. It's how you make the machine learn more effectively with human interaction. And it starts off with the training phases where you have those data labeling tasks, and how can you do it more effectively just by doing random sampling. And we're going to talk about a bit of the active learning framework. That is something that we see is not as used as it should be. And uh, we're going to see how it can help with the data annotation. You have also interactive learning, where you have a system that helps a domain expert to by themselves train machine learning models. There is also in this particular category the subjects around imitation learning, which is more related to the reinforcement learning paradigm, where instead of designing a reward function, you just show examples of what is the expected behavior that the agent should have with his environment. So this is for the machine teaching, and if you need to come out with this presentation with only one categories to be remembered of, it's the machine teaching, which is the most important. But machine teachings will also can rely on system design and how one can design user interface and experience around annotation, visualization, and ensuring continuous learning. Because at the end of the day, machine learning models are part of projects or are part of solutions that enable humans to take action. And how do you enable the human to take action through your solution to help the model improve over time? So this is most related to the user experience fields. You have also the model evaluation, how the human can evaluate that the model is doing what it wants to do. So all these different topics around error management, model performance, robustness to inputs, and more sustainability, how one can evaluate that a given model has sustainability. For example, in Capgemini, we have worked on an open source libraries now that is AI Carbon, that's basically aims at monitoring the impact, the carbon impact of your AI models. So it's really something that we'll need to that is definitely growing in terms of challenge. And the fourth aspect is the interpretability. So once you have your model, you have learned, you have fit your models, you have now something that is good enough, that is maybe in production. How do you allow the users to interpret what are the model outcome? And these are also a key aspect of any, I would say, any AI project success, because no model is perfect, and you'll face situations where users will not be happy with the results of the model, and how if they just have a sense of why the model is failing or why the model took this particular decision, this prediction, it's really going to help with the adoption. So how do you ensure that the user can put feedbacks even when there is something that went wrong, so that they are blocking? And if you think about mainstream solutions, if you think about music streaming platform or movie platform, when there is a recommendation engine that suggests you a new movie or music that you don't like, you can tell the solution that you're not happy with it. And this is something that as a user, if I just see a suggestion that doesn't fit my doesn't fit what I'm looking for, and I don't have any action to take to tell the system that it's not what I want, then I will lose confidence. Not only lose confidence because the outcome is not what I want, but also because I have no means to interact with the system to let him know that something is bad. So the interpretability comes both ways. It's really tied to model evaluation, and it's basically also sorry. So a new and trending field is model adversary, and the human as model adversary, where human is required to find some blind spots, some weaknesses on the model by changing, for example, data inputs. If you think about, for example, if you think about autonomous vehicle and the image of the street, where if you change something on a stop sign by, I don't know, putting some writings on it, or if you think about an image when you add some perturbation, and does the model is still robust and gives you the expected prediction? And it's really also important, for example, if you think about an natural language processing projects, that to make sure that the model learn what you want him to learn and not just relies on some specific patterns. So if you think about sentiment analysis, if I change few words from a given sentence, but I still have the overall meaning that remains good or bad, thus the prediction is consistent after the attack, after the perturbation. So those are the kind of topics that is covered in the human as model adversary, but it's mostly an academic and research area, and it's not, I would say that it's not mainly used in the enterprise. And the crowdsourcing, but I won't talk about a lot about it, but it's more about how do you make sure that if you crowdsource your annotation, that the data quality is there, that there is no annotation artifacts that will impact the learning after. So now we're going to talk about the lessons learned on our project. So I won't be covering all the 6 aspects, but I want to make the emphasis on the matching teaching, and really what we see as not enough, what we see in the industry that is not enough apply, is the active learning framework. Like I said at the beginning, when you think about annotating data in the enterprise, if you are a bank and you want to set up a fraud detection system, you would have people to define fraud if you are talking about supervised learning system. And we cannot just outsource this expertise. It has to be from the from bank experts, from operational teams. And if you think about you want to build a contract analysis system that will check contract, extract clauses, classify them, suggest a modification of a given contract. Some project that we've done. Again, you have to talk to legal experts, and those people are really busy, and this is why we mean by scarce resources, because their domain expertise is quite scarce and they have a lot to do. So how do you optimize the interaction you have with them? And active learning proposes a really nice setup for that. And a second key benefit is like it is that you are able to spot data quality or labeling, blurry definition really early on in the project, versus just using a random sample and annotate them, because it will pinpoint it will highlight cases where the model is uncertain, and most of the time it's uncertain because it hasn't seen this kind of, either it hasn't seen some of these examples in the training set before, or you have some conflicts between labels in the training set. So these are the examples where the definition of labels can be blurry, and it's often the time. And then it allows an iterative collaboration with the domain experts, and it helps down the line with the adoption of the tool, because the experts are really getting a feel of what the model is doing by annotating examples that are confusing the model, if I can say. So just as a reminder, what active learning is a framework where you start with some labeled data, usually that you start with a random sampling. You train a machine learning model or multiple models to predict on a pool of unlabeled data. And once you get those predictions, you have those classes, those labels, you can select queries that you will submit to a domain expert to annotate those examples. And once they are annotated, just and those examples that you want to select are the ones that bring the more information to the model, I would say. So there are different strategies. There are different query strategies. One of the most used and is a common baseline is the uncertainty sampling. That if you work with a model, you just if it's a probabilistic model, you will try to select the models that are where the probability is quite low. So if it's binary classification problem, you'll try to find examples that are closer to 50%, because these are the examples where the model is unsure. So this is an illustration below where you have two different classes and that were generated with a Gaussian model. And here are two examples. One is with random sampling with 30 examples, and the second one is 30 examples that were labeled through active learning. And you see that it's really a sample classification problem that can be addressed with a linear model. And you see that just by doing this uncertainty sampling, you have a huge gain in accuracy. And this is obviously a toy example, but just to show you how it can help with bringing solution quicker and with the proper use. And you see that those examples that were labeled are closer to the decision boundary of the model, because those are the ones that bring the more information. We don't need to label all those examples. So it is a basic principle. There are some tools that are open source. I won't go into it in a deep dive mode, but basically the key takeaway is that when you have a multi-class classification problems, so in the binary class classification problem, it's not that obvious that active learning will help you with a lot of time gain. But if you have multi-class classification problem, you definitely need to go with active learning. And another thing that is really important is the diversity sampling. So we talk about the uncertainty sampling. And another aspect of how to select sample to be labeled is to think about what the model, what it's not available for, either in the training set or in the already labeled data. Think about if you had a third cluster, that the model will be really confident to put it as a green class, but it's basically a third cluster. And this is what I mean by diversity, because if you don't label those examples and you go into production, there will be an error remediation to make because you haven't seen those examples. And so these cannot be addressed automatically, but can be addressed with the domain expert, meaning that we have to we have to make sure that the training samples not only we label the examples where the model is uncertain, but also where there is a representative set of your feature space. So about the lessons learned on the model evaluation and system design is that we see a lot of data science teams and project teams working on AI solution that get stuck in the model performance loop, trying to evaluate and fine-tune models where there is no clear objective on what is the business value that should come out of this AI solution. And these are examples that it should be obvious, but in practice, you have a lot of those examples. And if you don't define what is, from the business perspective, a success for this project and what the AI can help the business extracting value, whether it is by increasing sales, reducing costs because it's an automation project, or so. Coming back to concrete examples, if you think about fraud detection in financials, in banking, if you want to reduce the false positive rate of fraud for anti-money laundering, and there is a false positive rate that is historically with heuristic rules at 90%, and you want it to have it at 50%. So this is the objective that you want to measure, and it doesn't end with the business, with the machine learning performance, because at the end of the day, the machine learning is used to take some action, and a lot of problems doesn't necessarily come from the machine learning model, but comes from what comes after that. And this is the third part of the third reason why AI projects fail. One is that there is no clear business problem, Two is the data quality that cannot be we cannot leverage because the data is too messy, too noisy. Three is the collaboration, and collaboration between teams that are building the AI system, people that are using it, and people that support the deployment of those systems. We talk about operational team, that production, IT, etc. And what we see is that we often put a lot of emphasis on the performance metrics of the models, but we don't track KPIs on whether people take action after the machine gives its outcome. So if we talk about again another project where for a large bank we had this automation project to extract data from documents, normalize it, and prepare it for another analysis that should reduce by 70% the time that they spend just inputting the value manually. This is the business value. This is your objective. And it's a shortcut to say if you have a 70% accuracy model, we'll reach it. No, you won't. Because first of all, if it's 70% accuracy model and you have 30%, if you have 10 data points to extract, 7 are correct and 3 are wrong, you have a 30% false positive rate. And if you don't have a smart human in the process, just by saying that there are 30% of positive rate, people will not use it because they will lose confidence, because anytime they will see an error, they will want to cross-check everything. So the key here is not that the accuracy, it's the precision. You want something to have a higher precision, and you can have, it's okay if you have 70% accuracy, but don't have 3 out of 10 false positive. So these are the examples to say, okay, machine learning models evaluation is important, but you need to see if there is actually a business value that comes out of that. And so that means monitoring user action, user engagement, letting user the possibility to integrate with to put back their feedback into the system. Whether it is fully automated or not, it's important to let this possible. And I will conclude by, because I'm really out of the time, that I will conclude by saying a little word around interpretability, because again, I think it's one of the first comment I did in the beginning. If you have a system that is really performant, that gives, in terms of accuracy, a really high score, but there is no interpretability, there is no model that is perfect. And once you have examples where your model is not good enough, but you don't provide any insights around why the model did this mistake, you lose trust and you lose adoption. So these are the questions that you need to ask at the very beginning of the project, is how do we ensure that the user have a sense of what the model is doing, and not in terms of, so if you are working for radiologist and you're working on a breast cancer detection, and you have to classify image whether there is a breast cancer or not, what are the area of the image that are the more insightful for the model to take this prediction? Or if you are working on the fraud detection I was talking about, what are the different variables, different features that leads to this prediction, whether it is the for the profile of the potential fraud. And if you are working with the third cases I was talking about with the contract analysis, this clause is classified as the responsibilities between the parties. Okay, what are the part of the paragraph that you can highlight for the users to understand that, okay, there are some understanding that the model is doing that lead up to this decision. And this is really key, I mean, to be able to, gain adoption and have AI solutions that are actually useful for end user. Thank you very much. Please feel free to contact me if you have any question. And it was a pleasure. Thank you.